Welcome to the latest TezTalks Radio episode. As many are aware, we're currently in the testing period for Protocol 007. There's still a few questions lingering around, so we'll try to get into some of those today. We have myself, William McKenzie of Tezos Commons, Brian Lee of Tezos Commons, and Gabriel Alfour, the lead developer of LIGO Lang and one of the people behind 007. How's everyone doing this morning, night, and afternoon?
You go first, Gabriel. How you doing?
Quite well. Working on assembling a new team to work on core matters. Takes a fair amount of time, but it's really exciting. And that's mostly what's taking up my time lately.
Glad to hear. Yeah, I'm doing well as well. I'm the one who is doing this at night here. So I'm very excited to dig into this conversation. So Will, can you get us started? What's on the list of topics first?
Sure. So Gabriel, we usually ask everyone who comes on here this, but could you go into your background a bit and maybe discuss your journey into crypto and how you ended up where you are?
Yeah, sure. It started a few years ago. Basically, when I was younger, like when I was still out of age, I wanted to have my own company, to have my own bank account and online activity. And I could not. My parents were not internet savvy. They were not at ease with all those matters and wanted me to focus on school in general. So back then I was already quite interested in crypto because of those reasons, because of how it could make you independent, basically. It still was not quite as developed as I wanted, like so that anyone would use crypto and things like this. But because of this, I was very interested for ideological reasons. Like it was myself as a child, but I could easily imagine the situation of everyone else who needed the same kind of access that I did. But I kept going at school. Later, I actually needed to make money, and crypto is a really nice way to make money. As most new fields, there were a couple of other fields that I could have been interested to, such as AI and things like this. But I was mostly drawn to crypto because of the ideological part that I felt very aligned with. Back then, I was mostly interested in layer 2 solution. From a point of view, I expected layer 2, like most activity in crypto, to just move to layer 2. So I wanted to create my own blockchain that was mostly about bootstrapping layer 2. And at that point in time, I got a mail from the account mailing list that says, hey, we're building a blockchain in France. We're paying you well. We are like a self-amending blockchain. So whatever you want to add, you can just add it to our blockchain and things like this. And I was very interested. I didn't care about the blockchain being my blockchain in particular. So the idea of having a team already working on something that I could just improve on to add the features that I wanted was very attractive. Mm-hmm. Although I never wanted to be an employee, they were like very amendable, let's say. I could work remote full time. I could work whenever I want as long as I delivered and things like this. And that's why I came to work for Nomadic Lab, like back before it was Nomadic Labs. And after a year of this, I went on to make LIGO because the only programming language back then was Liquidity, and we needed an alternative. And now, a year after LIGO, I think it's in a pretty good shape now, and I mostly want to work on core again. It's not in the state that I hope it would be, and so I hope to be able to contribute to this.
Yeah, that's a pretty exciting story. Could you talk a bit more about the development of LIGO?
Yeah. So about LIGO, there are many different ideas, but the main one, which is the thing that takes a lot of time, is to have a simple core. Like in a lot of programming languages, you have this thing called the AST. The AST, the abstract syntax tree, is basically the internal representation of your language, and it's not shown to users. So usually that's where you will see a lot of technical creep coming, and the ASTs will become like very large, hard to maintain, and things like this. And as users, we do not really care. But if you want to do any kind of formal verification of your language or certified compilation or building tools and things like this, it is quite crucial to have a simple AST. For instance, if you look at a camel and its AST or the typer, those are like notoriously and famously a big mess, which makes it hard to hack on the language. I basically wanted the opposite for LIGO. I think it's really important for a blockchain programming language to be simple so that you can do formal verification on it directly, and so that you can actually try to do certified compilation. Certified compilation is this idea of writing a compiler that also has a proof that it's correct. So the idea is that if you have a certified compiler, you can reason on LIGO directly rather than having to compile LIGO to Mikkelsen and then reason on Mikkelsen. So that's what I've been trying, and I think we managed to do so successfully. We have a prototype for the biggest part of the compiler of a certified compiler. For the people who are technically interested, we basically have something that goes from a kind of Lambda Calculus to Mikkelsen, and that has been proven in Conc. So that's really cool, and we're working on integrating it. Other thing that it let us do is to have multiple syntaxes. For instance, you know that there is a Pascal LIGO, Camel LIGO, Reason LIGO, and they all have the same internal representation, so you can go from one syntax to the other quite easily.
Right.
And, we're also creating a new language from scratch, so we need to build tools, and we now have language server protocol extension for VS Code. We're adding it to Emacs and things like this. And it takes much less effort than it could have taken with a more regular programming language with a big AST. So that's mostly the main focus of LIGO, making the internals simple. It also means that there are some things that we don't do that could make the developer experience simpler, as it will lead to technical creep. And we're aware of this, and to fix this, I'm mostly planning to fix the problems that are in core, at the core level, at the Tezos level, rather than doing patches at the LIGO level, because this is where I am. That would be a wrong reason to do so. So that's mostly the main philosophy.
Awesome. Well, that is actually all pretty cool. You just talked about a whole bunch of stuff. So I just want to get into it a bit more, because I think a lot of our listeners here, they're not extremely technical. So the more that we can kind of break things down and talk about why these things are important, I think it would be better. So I've actually prepared kind of a small list of questions about LIGO. I'm not really a developer myself. I can do a little Python. I can do a little Golang, like everyone can, right? Certainly not to your level, but I think that we can dive deeper into this a bit. And one of the most interesting things that is on my mind is just, I've never actually talked to someone who designed a programming language. So from a meta perspective, I just want to know, when you're designing this new programming language, what exactly is the process for that? I feel when I hear, oh, someone is designing a new programming language, the first thing that comes to my mind is are they writing that in another language, or is it the language that they're designing? Can you talk a bit about that? This is just from my personal kind of interest.
That's a super great question, actually. In general, I say that there are three ways that you want to do something that important from scratch. The first one will be to base yourself on theory. So for programming languages, we have formal models of what is a programming language, and the most famous now one is Lambda Calculus. So Lambda Calculus is a minimal programming language with only functions, and that's it. And there have been decades of research on Lambda Calculi, all variants of Lambda Calculus, all type systems, all interpreters, like everything that you can imagine, it has been done on Lambda Calculus.
Yeah.
So if you wanted to design a programming language based on theory, that's what you would use. The other approach will be to make one based, let's say, on practice. What I mean by this is that you will take an existing programming language and then amend it so that it fits your goals better. An example of this will be, for instance, ReasonML. ReasonML is not an entirely new programming language. It's mostly taking OCaml and making it easier for web devs. Another example would be TypeScript, where you have JavaScript and then you add a type system on top of it. So that would be the approach, the practical approach, I would say. And the last one will be the one based on authority. So there you will just find like someone who did a great programming language and then ask them to make a programming language design for like to your constraints. It's a bit of a leap of faith. You have to trust that person. But if you know like a genius, that could work basically. So for LIGO, I prefer to take the theoretical approach. So the core of LIGO is very similar to Lambda Calculus with some extra constructors. The idea is that once you have this, you can reuse all those decades of theory. If you want to do static analysis, if you want to do formal verification, certified compiling, and things like this, you can just reuse those decades of research and be way more confident than in an entirely new model that you would have come up with. There was the possibility of picking something practical, but the problem with practical things is that there aren't that many good practical things for blockchain right now. We still have a lot of experimentation and things like this. And rather than participating in those new experimentation, I prefer to take something that was more general and more well-established, basically.
Yeah, I think if you're building something with a focus on safety, I think that's a very important aspect.
Yeah, that was mostly my main concern. Before doing LIGO, like as a lot of geeks in this realm, I made my own programming language, which had a very different focus. It was mostly on theory, not on practice, not on authority. It was an entirely new idea of myself. It was really complicated. The developer experience was terrible. It was not meant to be widely used. And so there, I had a completely different design process. That it was obviously not something that I would do for a smart contract language.
That's awesome. That's something that I've always wondered, like as someone who's trying to start to dive into coding. It's just like all these programming language, like how do they get made? So thanks for that. Thanks for that dive into that. So the next thing that I want to get into is LIGO's role in the Tezos ecosystem. So as we know, all of these things kind of compile down to Mickelson. So I think some people might be asking like, oh, why doesn't everyone just write it like in the base language? Like, why do we need these like high level languages that maybe help the developer workflow? Like that might be the main need for that. But can you talk about LIGO's role in the Tezos ecosystem, like pros and cons compared to writing directly in Mickelson, and any other thoughts on that?
Yeah. Then I think the question is not that much about LIGO, but more about Mickelson.
Yeah.
But yeah. So the fact that you have to ask this question shows that there is something wrong. By that I mean that let's say you're writing in Golang, you will never ask someone writing in Golang, why are you writing in Golang rather than assembly or something like this.
Yeah.
It's obvious that assembly is designed to be efficient for the machine, and Golang is designed to be efficient for the developer. And so it should be the same thing with LIGO and Mickelson. Mm-hmm. However, the ambiguity comes from the fact that initially, in the initial philosophy of Tezos, we wanted mostly small smart contracts that were publicly auditable. So you would have this simple language that was like a Turing-complete, better version of Bitcoin script, right? Mm-hmm. And the thing is that this experiment didn't pan out. People do want to write complex logic, and we need complex logic and things like this. So that's why higher level languages were developed. But yeah, that's why it sometimes feels like Mikkelsen is, between a low level language and a high level language. So given this, I think it's really important to move on to higher level languages, because Mikkelsen wasn't designed as the most efficient VM possible. And if we want to move to this, then people should not get used to think in Mikkelsen terms, and rather in higher level terms, so that when we move to a better VM, let's say a VM that is close to some assembly language, their whole training in Mikkelsen doesn't become obsolete or whatever. So right. I think higher level languages like LIGO should be the right level of abstraction to think about the blockchain.
Yeah, that makes a whole ton of sense, because I mean, for this episode, and I think for maybe one of the previous one or two that we did, I was kind of looking into Mikkelsen a lot and just reading through the syntax. I can kind of see why you wouldn't directly want to write in this language. So having something like LIGO, which is more writable, which is more readable as well, which is very important. I think that really enhances the developer experience for the ecosystem.
Agreed. Also, LIGO is more similar to regular programming languages. So the learning curve is much smaller, and you're less likely to make mistakes, which the blockchain realms are quite costly, to say the least.
Right. Yeah. Extremely costly, as we've all seen in the past month or so. So the last thing that I had on my mind, and this kind of builds on what you just mentioned with regard to being more similar to certain languages. I did notice that LIGO also supports a various number of syntaxes. There is Pascal, Reason, and OCaml as well. And on the website, I also saw the words you can build your own syntax. So can you kind of talk about why LIGO currently has Pascal, Reason, and OCaml? I'm interested in programming, and I just want to know if there's a reason that these three were chosen, as well as if someone were to quote unquote make their own syntax, what would be the high level steps for someone to do that?
Yeah, sure. So the reason for those languages are more coincidental than carefully designed 3 years in advance or something like this.
Got it.
For Pascal, the reason was that we wanted some imperative-like language, and we already had the parser ready and well-maintained and things like this from Christian Rinderknecht working with us. Mm-hmm. So we had a solid piece of software that worked, so we reused it. For OCaml, the reason was twofold. The first one is that we're in an ecosystem that relies a lot on OCaml, so a lot of developers who know OCaml will be able to translate their knowledge quite easily. So that's the reason for OCaml. The other reason was that Liquidity was OCaml based, and so we wanted to be compatible with Liquidity at first. It was quite important back then. And the last one, Reason LIGO, was because simply a lot of people asked. We said that we could make a new syntax and things like this, and a lot of people were interested in Reason LIGO. And the other person working on syntaxes on our team, Sander, comes from the Reason ML ecosystem. So we had all the ingredients for the syntax.
I see.
We can add more syntax. We already had a prototype 4 months for a Python-based one, and we might make a JavaScript-based one quite soon, C-like, JavaScript-like. The only thing that we're waiting right now is for refactoring of the front end, so that implementing a syntax will just be a matter of implementing an OCaml module, basically.
Right.
So you have this very clear thing where you have a module type signature, which is a bunch of things that you have to implement, and then you implement all of them, and you know that your whole syntax is done. So right now we don't have this. So rather than a single module type signature, if you were to add your own syntax, you will need to get into the front end library basically, and you will need to copy paste an existing syntax, which will be quite easy, but not as fully understood as just implementing a module type signature, basically.
Right.
Right now, you can just go into LIGO's GitLab repository, go into the front end folder, pick a syntax that already exists, like camel LIGO, reason LIGO, Pascal LIGO, copy paste the folder, and make your own changes.
Yeah, thanks. Thank you for getting really deep into that. We'll be sure to include links to ligolang.org so you can read more about it if you're interested in writing a smart contract for Tezos. So with that, I'm going to hand it over to Will, and let's move on to Protocol 007.
Sure. So I guess for our first question, prior to injection of 007, there was a lot of talk, and I believe sapling was expected to be in the next proposal. Gabriel, could you explain the timing and rationale behind 007 for those who may not be aware?
Yep. So
the big question.
No, it's more that I had a lot of feelings associated with this.
Yeah.
Right.
So the nice way to put it will be to say that we basically failed with our release process. What I mean by this is that we have a completely new thing. Blockchains usually don't self-amend, so you don't usually care about the protocol code that much. You have some kind of hard forks for security patches or things like this, but usually it is very stable. However, here with Tezos, given that we want to change our protocol, we have to care about a whole lot of new things that other blockchains simply don't. So we need to have a good release process, a good merge process, a good way to pick the features that we want to add while keeping consensus so that we don't have to ship out multiple competing proposals, which will be detrimental to Tezos. But if needed, we could, but it's better to have a consensus. So we need to worry about all those other things on top of managing technical debt and the like. The problem so we are all new to this. No one has done anything comparable to this, to my knowledge. So we needed to tackle new problems, and what we wanted to do was to do a release with, for instance, sapling in it, and not do anything before that. That was a quite bad idea, because the problem is, let's say you had some features ready 6 months ago. Then you will need to wait for sapling, and a whole bunch of other features will need to wait for sapling, and this fact will make the merge request, the new amendment grow bigger and bigger. And the problem when your amendment grows bigger and bigger is that the needs for reduce grow bigger and bigger, and so on and so forth. And so at that point in time, we had this very big amendment that no one was very, very confident in. And the choice was made to trim it down to what we were fully confident at that time, and just ship so that we can move on to this new release process that is more time-based rather than feature-based. And I say I have some feelings about this because, for instance, in the new amendment, you have a bunch of McKenzie optimizations, which I've worked on and with Nomadic. But I actually wanted to do much more, and I had a prototype ready 4 to 5 months ago of a much better McKenzie interpreter. So it's kind of bittersweet. On one hand, I actually had the time to make the full new interpreter back then, even though I was told that the next amendment will come in a month or two. But on the other hand, now with Delphi, we actually moved to a time-based process, and I'm quite confident that we will never get such a problem ever again. So what it means concretely is that whenever we need a new feature now, one can just develop it and have it accepted and be confident that it will be merged in the next 3 to 6 months, as opposed to before, where we basically had 6 months or more than this actually without a proposal. So yeah, it looks a bit rushed, and that is the case. It was rushed because we trimmed it down, and we put a lot of time in reviews and testing and things like this. And that's why there are much less features. that's that was like a necessary step from our point of view, and it's good that it's now in the past, and that we will now have very regular protocol amendments.
Yeah, and anything you said there, you don't want in, we'll be sure to cut that out. Just a quick note. But moving on, we recently saw the release of Dexter. Gabriel, can you perhaps discuss how improved performance and reduced gas costs can help create more DeFi applications for Tezos?
Sushi. Let's not have another sushi, right?
Yeah.
Tezos sushi.
That's one of the most straightforward questions that have been asked so far. Basically, when you develop a new smart contract, you regularly encounter in Tezos two limits. The first one is the limit of the size of the contract, because storing data on chain costs money, basically, and we have a limit on the size of the data of your smart contract. So with a bunch of those optimizations and things like this, we can have like bigger contracts, and we could increase the limits. And the other one is the runtime limit. So every time you run a smart contract, right, you need to pay a price, which is the execution price, so that, for instance, people could not spam the Tezos blockchain with millions of transactions that just take a lot of time out of the bakers and just toss the chain and hold the chain. So that's why there is a need for such pricing of operations. And basically, the more performant you make your interpreter, the more operations you can fit, and the less you have to worry about this limit when you're doing like a DeFi contract. And if I remember correctly, for like a lot of smart contracts, we had basically a 4x improvement. So it basically means that
wow, that's a big improvement. Yeah,
that's quite cool. So it means that you need to worry like 4 times less about the size of anything that you do. So it's a quite straightforward question. The more efficient the interpreter is, the laxer the limits are, and the less you have to worry about them when developing on Tezos.
Yeah. So outside of DeFi, what current limitations are there on Tezos on mainnet, and how will 007 help address some of those?
So there are two parts to the question. The first one is like what kind of limitations we have, and the second one is which one will 007 address. So 007 is a minimal amendment that is more about the release process itself and the features that it comes with, and it mostly addresses performance. So it won't address the other problems that I will mention. So from a point of view, when you want to do a new thing on Tezos right now, you will basically have, I would say, 3 kinds of problems. The first one is performance, which is addressed by 007 and by a wide margin. The second one is common to all blockchains. It's concurrency. So concurrency is a big problem in computer science. It's when you want to have multiple programs on blockchain smart contracts interacting with each other. Whenever you hear about like an exploit on Ethereum, it's always a concurrency issue. Reentrancy bugs are just like we fucked up with concurrency. So the question is how to manage concurrency on blockchains. Before answering this question, you might care about how do we manage concurrency in regular programming. And the answer is that we don't. It's very painful and leads to a lot of problems. And for instance, if you look at the web, like web programming, you constantly have new frameworks. At first, you just had the DOM, then you had jQuery that lets you manipulate the DOM in a better way. Then we had Angular, React, and all those things, with reactive programming and all those things that are always about managing multiple competing piece of states and making them interact well. And the answer is that it's just really hard. And even in regular programming, we don't have a definite answer. And if you look at blockchains, it's even worse. Like blockchains are the hardcore mode of programming. When you write a smart contract, you cannot change it anymore. So it means that if you have a bug, then you have a bug, and that's it. It's not like regular programs where, like in your front-end application, you can just push a patch or whatever. The second thing is that blockchains, like blockchain contracts, blockchain programs, have much higher stakes. Everyone want to pump them so that they can get the amount that is staked in them, basically. And the last problem is that, let's say I'm making a financial application in the regular world. I can just host it on my server and not expose the source code to anyone. People will just interact with requests to my server, like on their browser or whatever. However, with blockchains, all the code that you write is public and open source. So in blockchains, you have to manage concurrency in a very adversarial environment where it's open source and where you cannot make patches. And the answer is that this is very, very hard. And it is hard in Tezos. It is hard in a lot of other blockchains. In Tezos, to alleviate this, what we did was pick message passing style for interaction between smart contracts. So what it means is that if you have a smart contract, let's call it A, and you want to call a smart contract B, then you cannot just call B in the middle of the execution of A. You have to wait until A is over so that you send a message to B so that B does whatever it needs to do. And the advantage of this model is that you don't have two contracts being executed at the same time as you have with Ethereum. A reentrancy attack is when you have a contract calling another contract that calls you back, basically. So you have multiple competingly executed contracts. Whereas you don't have this. A single contract is being executed at a given time. The problem with this is that the developer experience is terrible. It's a really hard model. If you want to just get the data of another contract, you have to make basically two new operations. It's not efficient and things like this. So it's safer than Ethereum's in that you don't have to think about two contracts being executed at the same time. But it's harder in that you still have to emulate this functionality yourself. So it's only in 007, but there are like a couple of things that I've worked on that aims to solve this problem, or at least mitigate it. The first one is views. The idea of views is that you can just call another contract to get some of its data, but that other contract cannot do anything but show you its piece of the data. The technical reasons why this makes sense are complicated, but what matters is the developer experience. For the developer experience, what it means is that you can just access the data of other smart contracts like regular function calls. So that's the first use. It might come in 08. And the second one is tickets, which will definitely come in 08. The idea of tickets is that you to add a new data type that represents a permission or a token. And the idea is that you can just send it to other contracts. So it means that no contract like ERC20 or FA2 or things like this have to represent the state of all tokens of all contracts. It's just your contract holding its tokens. It makes for a much more intuitive model. Rather than a ledger, you just have your cash on yourself, your assets on yourself. And a much safer one and much more resilient to concurrency. Tickets still make sense in a fully asynchronous models with shards, with layer 2s and things like this. It's a quite neat model. This one is informed from object capabilities, which I believe have been developed by Mark Miller. And we spend a lot of time trying to put it into Tezos. And basically, once you have tickets, it should become quite easy to have like smart wallets with advanced permissions and things like this, where you just have to send the equivalent of a token to another contract that will represent your permission. So those are the two things that we're doing to solve the concurrency problems right now, which are views and tickets. And the last problem that you might encounter on Tezos right now is the lack of a fully automated way to interact with a smart contract. What I mean by this is that when you have a smart contract, you want to interact with it on chain. So you have the interface and the entry points, but you also want to display stuff off chain. For instance, in your wallets, in indexers, in applications, and things like this. And right now, you basically need to write by hand solution. There is no standard solution for this. So a couple of standards are being developed, like TZ16 for metadata and things like this. But the easiest thing will be to add it into the protocol. And it might come to either 08, which I'm not confident in, but 09 definitely. And the idea is that you will have views, you will have events, you will have metadata, you will have functions to be used by indexers and things like this. And you could just develop your contracts with those, and then all the tools will take care of this. It will be integrated in wallets, it will be integrated in block explorers, it will be integrated in indexers and in applications, like very easily without you having to do anything. So that will be the last thing. So just to summarize the three problems that you might encounter when building apps will be performance, which has been addressed by 07 and will keep being addressed in the future. The second one was concurrency, which will be addressed by at least partly by views and tickets. And the last one is automated interaction and tools with your contracts, which are being worked on both with new standards like TZIP16 and protocol amendments.
All that is really interesting, and especially the security talk. Like, you see all of these talks about hacks and stuff, and you read all of the news articles on Cointelegraph or the Block or whatever you read, but like the term concurrency, you never really see that term in these kinds of things, and it makes me really want to look into it because I've never really read much about it. I just did a quick Google search and I see some stuff about concurrency on Ethereum, but it really makes you think like blockchain is really the perfect storm for malicious actors to attack, right? First of all, you have this kind of novel way of executing code across a bunch of decentralized nodes, which was not really possible before, and you have all this code and you have to kind of account for like the latency and stuff like that. And then you also have, like you said, the open source code where anyone can read it online. And if they have this like slight edge over the devs and they can spot a bug or something in that code, they can instantly like manipulate that and make a ton of money for themselves. So that's like, it's just like the perfect storm for malicious actors. And now that I know about this like concurrency thing, I'm just so surprised that there's a lot of chains out there that haven't been attacked. And I have to ask if it's like a question of they haven't been attacked yet. Are hackers constantly kind of monitoring like the code bases for these slight edges that can be used to basically like bring down the chain, cause some issue, like mint some tokens? Like, this is like kind of off topic, but do you have any thoughts on that? Like the biggest hacks we've seen in recent history, I guess, are kind of Ethereum smart contract related, but there's so many coins out there. So I just wanted to get your thoughts on that.
It's a quite fun question. So I don't know much about the hacker world, so I can only speculate. If I had to basically, the thing is, for instance, with Tezos, it wouldn't be worth for a hacker to learn about Mikkelsen and things like this, because Mikkelsen will likely change, for instance, in the next months and things like this, where we keep being improved and things like this. But for blockchains that are stable, it can actually be worth it to dig into their code base and look up smart contracts vulnerabilities. So then it's just a question of opportunity cost and things like this. In blockchains that are stable, which one have the highest stakes in their contracts? Which one have the worst developer ecosystem? Questions like this. And also past a certain skill threshold, like let's say you're that super hacker who can hack any contract and things like this. Just like worth better to just hack legacy applications or do yourself some research or write your own startup and make a unicorn or whatever. Those exploits still require like a high level of skill.
Yeah. And the way you execute it too, I guess, has to be.
Yeah. I'm not talking about execution and laundering money and all those things. Yeah, I'm literally just talking about the hiding part. So
right.
It might explain a fair amount of it, but that's a really bad model of security. It's not what we should rely on. Most of this model will blow up as blockchains become more and more widely used. I think concurrency is a ticking bomb that has exploded and will keep exploding in the incoming years as blockchains are more and more widely used.
Yikes, that's scary, but like in a way, I guess with newly developed technologies, it's kind of a growing pain.
Yeah, exactly. And like you said, for instance, the term concurrency itself is not that much used in blockchain. We usually talk about security in a very abstract manner. And if you look at Ethereum, the way that those issues are solved are like, with an FAQ where you have recommendations about how you should write your contracts and things like this. But like, you don't have a neat model of how concurrency works and should work and things like this. It's still a bunch of ad hoc patches, basically.
Yeah.
Whereas if you look at the literature in the research of the past decades, you have a lot of framework to deal with concurrency, like so many. You have a huge literature, and it's not really that widespreadly used in blockchains yet. We'll see.
Wow, sounds really interesting. I actually have a vacation the next few days, so this might be some good stuff to try to read. But Will, you want to get back on track? I think there's a few more questions about the new protocol upgrade coming up.
Yeah, so that was a very interesting discussion.
Tangent. I always go off topic, so yeah, go ahead, Will.
No, it's fine. One of my favorite features of the amendment process is invoicing. And it's, kind of the idea that you can essentially name your price as an invoice attached to a proposal and have the community and token holders, be able to essentially decide on funding your work. 007 did not have an invoice attached. So, Gabriel, could you explain why and kind of discuss where you see the future of protocol proposals moving forward?
For 007, I guess it was not deemed worth it, possibly because, for instance, sapling and other things were not part of it. So, people might have taken it the wrong way if we under-delivered and asked for an invoice or whatever. I admit I don't really care much for such considerations. I explained this was a necessary amendment to move on to a much better release process and things like this. And from my point of view, it deserves reward. But at the same time, all those people right now are being paid by TF, so that they are in part already being paid by the community. I'm not sure that invoicing is what's needed in the very short term. However, in the longer term, once we have our code base of the protocol in a much better state, once we have a lot of competing, a pipeline that goes from user needs to how it might be expressed as an amendment to an RFC and then to a merge request, then we will trace all these things, and then we could attach invoices to particular merge requests and then to amendments. And that will be great. If you want to go deeper into this, we could even go into prediction markets. So the idea is what? The idea is, let's say I make a merge request that adds, multiplies the number of TX per second by 100, right? I have this merge request, and then you will have prediction markets that are about the value of the Tez conditioned on this merge request being accepted into the protocol. So this gives you a market valuation of how much this improvement is worth. And let's say the market say that if the TPS is increased by 100-fold, then the value of Tezos is doubled. Okay. So I'm not sure what the Tezos price is right now. Let me check right now.
I think it's like $2, I believe.
Yeah, 2.5. So let's say that condition on the TEPS being multiplied by 100, we jumped to like $4.5. Mm-hmm. So what it means is that it's worth at least the entire, like this amendment is worth at least the entire market cap of Tezos right now. So you could use like at least this amount. Of course, you won't use the full amount, else there is like no value produced for a staker. So you like use, I don't know, 1%, 10%, who knows. But then it would mean that you could found new amendments purely through the expected, through their future expected value, which is a crazy idea. Like let's say you have it on the blockchain, you could then reuse the same kind of things for states. You could fund massive commons projects through the expected increase in tax revenue, through the increase of GDP. And that's the whole notion of futarchy. So I don't think we're there yet. In Tezos, we need...
Wow. Yeah, that's deep.
Yeah, it's really cool. So we need a bit more infrastructure. Arthur wrote some posts about it for futarchy in Tezos. I've mentioned like this whole pipeline where we get the features, then get them integrated into our seed and the merge request, then tracing all those things and then giving them the financial value and so on and so forth. But once we have this, it will be super great to have futarchy in Tezos. That's one of the main things that I'm interested in. I don't talk a lot about it right now because we're still not ready and I'm still working on the underlying infrastructure with other people. Right. But once it's ready, I think we should like go all in this. And I think here blockchains have the role of, I'm not sure how you call this in English, precursor, like the first people to explore something. And the idea is that if it works on blockchains, then you could then use this same mechanism for states, for big companies, and all organizations that need to price commons. And if you had this, you will have this future where you will have a market for commons, which is incredible. It means that you will get paid to do good. And you will have like a direct measure of your worth. So that will be a really great idea.
That's super awesome. You know, I didn't think about this invoice thing up to that scale. So definitely a lot to reflect on. It's just the magnitude of this and the potential of this, you know, if all of this goes mainstream in the future, I think it has the potential to be, you know, just extremely beneficial to society at large.
Yeah, agreed. That's why I think it should not be rushed and it should be done like a really maintainable way. Everyone can build on top of this.
Awesome. Well, I've got to say that was one of the best conversations about Tezos I've ever had. So I really want to thank you for your time here, Gabriel. So we're just about ready to wrap up here. We'll be sure to include all of the necessary links that we have mentioned in this podcast. Will, did you have anything else to add?
No, I don't. Thanks for coming on, Gabriel. Be sure to check out and learn a little bit more about LIGO Lang, and obviously stay tuned on the progress of 007.
All right. Thanks for listening, and stay tuned for the next episode of TezTalks Radio.